Hey guys, I'm Jeff and welcome back to my shop. Yes, it's been a couple of months. I tried not to let it go too long this time. There's a lot of craziness going on right now, and I hope that all of you are safe and healthy and hopefully not too horribly affected by this, at least any worse than it is. So this time of the year, the first quarter, I've noticed this as a pattern in the last few years, is I usually get a lot of projects that I don't have a lot of time to film and make videos of. So I've tried to kind of cut that off a little bit this year, and I took as many little short clips, videos, pictures, stuff like that, and I thought I would just go ahead and dump my SD card and my phone and all that stuff, and we'll just go through it. I'll make a variety show out of it. Hopefully maybe you guys can enjoy watching along with some of that, or maybe enjoy laughing at my work, anything, whatever.
Votre toast, je peux vous le rendre, Seigneur, Seigneur, car avec les soldats, oui, les toreros peuvent s'entendre, pour plaisir, ils ont les combats. Le cirque est plein ce jour de fête, le cirque est plein d'idiotes. Le spectateur est dans la tête, le spectateur c'est un peu après fracas. Apostrophe, puis c'est ta page, pour c'est jusqu'à l'empereur, car c'est la fête du courage, c'est la fête des gens de guerre. Allons, en garde, allons, allons, toréador, en garde, toréador, toréador. Et songe bien, oui, songe combattant, que le noir te regarde, et que la mort t'attend, toréador, l'amour t'attend. À quoi se passe-t-il? L'idée le taureau se lance en bandissant auditorie. Il s'élance, il entre frappe en chevelure, entraînant en pique d'or. Ah, bravo taureau, il le foule, le taureau va, il vient, et frappe encore.
This little imported 1x30 belt grinder is something I've had for, I think, like 7 years. It was one of the very first power tools I had when I first got an attached garage and turned it into a shop. It finally, over the winter break here, it finally died, and I thought, well, it must be dead for sure. After chasing it down with a multimeter, I found, no, it was actually just the switch to the motor, which I was able to replace just from a big box store. Had to modify the power box just a little bit. But it's just funny to me that, like, I honestly did not ever expect this silly little tool to last this long, and then, you know, the one thing that goes bad on it is pretty easily repaired. It's really handy. I've actually ground up a bunch of little knives and fun things like that on it and used it for sharpening lathe tools, things of that nature. Really handy little machine. I think they've gone up in price. It goes through belts kind of fast, but either way, it's kind of cool to have this guy back. The idea of lapping is really cool, where you take a material, usually a relatively soft material that has a very perfect dimension or flatness on it, and you use that to impress that dimension and flatness onto your workpiece with abrasives. I've learned about this from guys like Robin Renzetti and Tom Lipton, Stefan as well. What I'm doing here is making a bar that's perfectly 30 millimeters in diameter. This is aluminum, as you can tell by the horrible chip formation. And we're going to use this bar to lap in 2 rings. I want them to be coaxial, and I want them to be perfectly 30 millimeters. As some of you may be guessing, yes, this is for an optic. I'm taking measurements pretty often after every cut because, well, A, I'm having to hit a American standard for 30 millimeters. You can do the math on that yourself. I can't remember it off the top of my head. But I'm checking to make sure that I don't go under it. That will defeat the whole purpose of this and scrap kind of a big bar. And I also am checking for taper. I was actually pretty pleased. Only about a thou of taper over this 10 or 11 inch distance, which isn't horrible. Now, lapping plates, lapping bars, lapping devices usually have grooves in them for the lapping compound to gather, somewhere for it to go. So I'm doing that here on the lathe. I'm going to cut a 4 TPI thread, just a really, really, really coarse thread for this little lathe, which went pretty well, I think. I have to change the gears around. This is the first time I've done this since I rebuilt this lathe 3 years ago. And man, this is going fast. I should have put it in back gear. I didn't because it was aluminum, but that carriage is screaming fast.
Oh, man.
There was actually no problems with the cut, except for the fact that the thread chasing dial was getting bounced around by the lead screw so much that it actually missed the second cut of that first thread. I got it here on this third pass. It was a little frustrating, but luckily for what we're doing, I don't need to have a perfect thread. In fact, we're not going for a full depth of thread or perfect thread or anything. We're literally just making a channel. And as you can see here, I actually reversed the feed of the lead screw and cut that thread in the other direction to make somewhat of a crisscross pattern. And you can see the subject for the optic rings that we're going to be lapping. I'm just covering everything up. I've got the rings torqued down onto the rail, and then covering up everything that, could get any of the lapping compound on it. Now, available kits are out there for this exact purpose, and they usually use a mild steel bar, but these are aluminum rings. As you can see, this is a pretty lightweight platform. I'm actually just using valve grinding compound. This stuff is about 200 grit, and the grit gets finer as you work it, and you can thin it out with water. For this application, especially for just kind of learning, it was fine. After the compound is put on the rings, I start to slowly bring them to torque, and I'm just basically barely loosening them here. And we'll take a few passes with the bar and then gradually tighten them until we hit full torque. As you can see, something I didn't get on camera was drilling the cross hole for that little handle. What I probably should have done was moved the bar back and forth more, just to disperse the load onto the bar so I didn't so instantly wear out. I expected this, maybe not after this session, but after a couple, that bar will lose its dimensions and tolerance. It'll grind itself away. It's actually working, though. It had more effect on the bottom half of the ring than the top immediately, but I took a few passes of grinding and tightening and grinding and tightening. And when I say grinding, I mean moving the bar. And then I would clean it all off and apply some fresh paste and go over it again until we got pretty much all white metal, in the white metal, all the way around the inside of the rings. By the time I got to final tightness, I actually had to use this little cheater bar here, just a piece of DOM tube. And then, once I was done, had a good finish on the inside, we cleaned everything off and got it all mounted and torqued up to spec. And I guess it's been a few years since I shared a video like this with you guys, so here you go. Okay, this is going to be part of a bigger project, and it still is part of that project. I'm just not done with the rest of that project yet. This was late last summer. I'm cutting some stainless steel, 17.4 pH, and this is on my home-converted G0704 milling machine. Not a very big machine, not very rigid or powerful compared to a lot of them. But it actually cuts really nicely. You might see a little bit of vibration here at 100% speed. It turns out that tool was just hooped. It was dead. So that caused a little bit of heartburn in this cut, but it otherwise cut just fine, and we got it pretty much to tolerance. I thought it'd be cool to show. I don't remember the last time I showed this fixture, but it's just a 5C spin indexer, one of the really cheap imported ones. You can get very nice ones from places like Suburban Tool and things of that nature. There's other options for holding round parts on the milling machine, but this one's really nice for just quick and dirty little stuff like this, and just drilling a cross hole. We're using an adaptive to mill out the cross hole. It was actually going to be a little bit more square shaped, but the size of tool I chose, the radius of that tool ended up kind of an oval. I'm going down half at a time, or half of the width of the part at a time. That way we're not digging way down too deep in the pocket. And then I can just flip it over in this spin index, and 18 holes is 180 degrees, and just keep my same zero and everything, and actually just run the exact same code, and the two will meet in the middle. This tool being kind of imperfect, I had to really up the richness of my coolant mister, because it was starting to generate a little bit of heat, I could tell. As soon as I could, I replaced this tool, which also helped for the kind of quote-unquote finishing op of this part. And I got this 5/16. This is like a 2-inch cutting length. Really, really, really long, skinny, spindly end mill. It was very sharp. And then I could actually just go all the way through and then just do a pretty basic, easy, quick 2D profile. And because the spin index isn't perfectly accurate, there would otherwise have been just a little tiny, barely perceptible lip inside of there, and this took care of it. Not entirely sure why I have all this footage of cutting this little piece in brass. I think this was last fall I cut this. But anyway, enjoy. Just a little fun little part, kind of an around the shop thing. Anyway, thank you guys for watching. Like I said, I hope y'all are safe, sane, healthy, all that stuff out there. I have a lot of good stuff in the works that I've been working on in the shop during all this lockdown, this quarantine. Anyway, stay safe, stay healthy, and I will see you in the next video.